1, you have a k and you're multiplying it by k to the 4th. A lot of you have the right answer, but that's first try. So remember, if you have the same base and you're multiplying, what happens to the exponents? And what exponent is on this first k? So we've got k to the 1st plus 4th. So we have k to the 5th as our answer. Another way that you could see this, if you can't remember those rules, I don't care if you can't remember the rules. Another thing you could do is use expansion and say, well, this is k multiplied by k times k times k times k, k to the 4th. And then we condense it back together, and we have k to the 5th for our final answer. So if you don't remember the rules, you can always expand and then condense. Number 2, we are multiplying. So you're going to multiply things that you can multiply together, like 4 times 6. You're going to multiply together u to the 5th times u to the 5th. And when you multiply same bases, you write that same base and you add their exponents. We're going to multiply v times v squared. Same bases, write that base, add the exponents. I get 24 u to the 10th, v to the 3rd. Number 3, square this. If we are squaring, we are doing power. If you're doing power, what do you do to exponents? You multiply them. But some of these exponents you don't see. It's like this one is 5 to the 1st. You multiply that by 2, so you have 5 to the 2nd, which is 25. You get a to the 6th. You get b to the 20th. And then c to the 2nd. Another way you could think about this one, if remembering the multiplication of the exponents is not something as easy for you, squared means write it twice. You could write 5 times 5, a cubed times a cubed, b to the 10th times b to the 10th, and c times c. You could expand it all out. And you could expand it even further if you want. You could write a times a times a times a times a, that's a to the 6th. You could write out b times b times b 10 times, and another 10 times. Hopefully before then you realize there's just 20 of them, not 100. Hopefully you realize there is 20 of them, not just 12. If I spelled different answers. And then c times c is c to the 2nd. The next one started getting harder because you have to think order of operations. And order of operations says we do exponents before we multiply. So the first thing I have to do is I have to do this 4th power to the middle parenthesis. So I have to do 3 to the 4th, which is 81. I have to do x to the 4th. I have to do y squared to the 4th, and what do I do to the exponents? Multiply them. So y to the 8th. And then I do z to the 4th. That is now my new middle parenthesis, which is being multiplied by 3xyz, and is being multiplied by 3x cubed y. So I'm multiplying together 3 times 81 times 3. Those are the numbers I'm multiplying. And I did that by you could do it however you want. I did not do that by just typing in my calculator. Because I want my brain to get stronger and then think about it. And my 2nd grader can do it, so can you. For real. I might think about this being 3 times 3, which is what? 9. I'll write it over here, 9. And I'll multiply that by 81. Well, what is 81? 81 is the same thing as like 80 plus 1. So what's 9 times 80? 729. Yep, 720. That's my answer. 720. And then what's 9 times 1? So this should be 729. Or you can just like multiply that old school way too, where you're like carrying the numbers and you know what I'm talking about. That's another way of doing it. Alright, then we've got x cubed, we've got x to the 4th, and we have another x. So I've got same bases, add my exponents, I get x to the 8th. I've got a y times a y to the 8th, and another y. So I've got y to the 10th. And then I have z to the 4th times another z. So z to the 5th. Half of you, I walked around and thought you wrote 2 to the 5th, and I had to double look at it. What's that called? Double take? Yeah. I had to do a double take. Because you make them look like 2s, and then I think it's a 2, and then guess what happens when you use this number later and you forgot what you were doing, you think it's a 2. So I put a line in it. After being a teacher long enough and seeing so many z's that look like 2s, I started just training myself to put the line in it so you at least know what my numbers are. But that might be something that will be helpful for you. You put the line into the z so that you know it's a z and not think it's a 2. I also do the same thing with 7 because 7, sometimes people pick up their pencil late and it ends up looking like a 2. So I put the 7 in line. It's fancy. Not fancy. Okay, number 5. This is where some people had trouble because of the negatives. So this one, we have to do order of operations. We're going to do powers first. So right here I've got a power of 3. It means everything happens 3 times, right? That means I've got 3 negatives. 3 negatives is the negative. I've got 2 to the 3rd. I've got g to the 3rd, and I've got j to the 9. This parenthesis over here, I've got negative, but it's happening an even amount of times, which is positive. And then I've got g to the 4th, h to the 4th, and j to the 4th. The first one here does not have any power, so that one stays negative. And then I go to multiplication, and I have a negative times a negative, so that's positive. And then I've got 2 to the 3rd, which is 8. And then the g's, 1, 2, 3, 4, 5, 6, 7, 8, 9, g to the 9th. I've got 1 h, 4 h's, h to the 5th. And then 9 j's and 4 j's, so 13. All right, and then number 6, 2x, y to the 5th, we have to multiply that by the negative to the 4th power, which is positive, and then y to the 4th is 1. So the stuff that has the like bases, we can multiply by adding their exponents. 2xy to the 9. Good review. So today we're going to learn about roots. Have you ever heard of roots before? No. Well, I'm glad you know where roots grow, because that'll be helpful later. You'll laugh, but it'll be helpful later. In math, have we ever said anything about roots? Square roots, yes, we are familiar with square roots. A square root would be when you find what multiplied by itself gives you this number underneath. So what times itself gives us x squared? What times itself gives us 64? 8. Those are square roots. But since we have things like cubes, we also have things called cube roots that look like that. So this number here, this cube that is really tiny and it's inside the little radical, is the index. It is our root that we were trying to find. Just like a square root, this one we're trying to find the cube root. What cubed gives me 5 cubed? 5. Yeah? What cubed gives me 5 cubed? What cubed gives me 8? 2. So is that it? Square roots and cube roots? Think that's it? No, it could be any roots. Anything that you could take to a power, you could also do a root of. So here's an example. If 3 to the 4th equals 81, then 3 is the 4th root of 81. And the nth root of A is written as, here we have the nth root, and then the radical would be where we say of, and then A would be what we're taking it of. N is the index of the radical, I already said that. The 4th root of 81 can be written as, I'm just writing it bigger, but it's written there for you. 4th root of 81. 4 is the index of the radical. Does anybody know what to the 4th power gives me 81? 3. That is the 4th root of 81, plus it's right here. So. We're not really using our calculator. This is just to maybe see some patterns, to develop our rules ourselves and kind of learn by experience. So it says to use your calculator to evaluate the following expressions. So if you have your calculator, square root of 9, you guys know where square root is on there? I hope you know the answer for square root of 9. Good. But then to do 9 to the 1/2, you're going to do 9, and then your to the button is this caret right here. The caret. And then depending on your calculator, it might look slightly different. If you have the newer calculators, which a lot of you do, you could do alpha y equals and make it a fraction up there. If you don't have the new calculators, you could just do parenthesis 1 divided by 2. Because fraction bars are division. Either way, you should still get the same answer. Okay, I'm going to stop talking for a moment. I want to see that you know how to type in 3 through 8 and find answers. We're not, yeah, we're not for the most part, but. Ooh, the cube root, good one. Number 5.
I have for
Wait, what? Let me get back to you. I don't think so, but I can't say not. Did it work? Do that for 4, not for 5. Give me a number that I would understand better. Okay, so it radicalized it. It did the radical part, and then it also precipitated the answer. If it's like 2, you get a half. Number 5, it says cube root. You might not know where that is, but it is on your calculator. Good. If you're ever looking for stuff, a lot of times it's under the math button, which is right over here. See, it says math. A lot of stuff's over there. Go to math button, and oh my gosh, there it is right there. Also, right underneath it, number 5 is when you can put any root you like. So for question 5, cube root of 8, I'm going to choose cube root and then 8. But you should know the answer to that already. And then the next one is 8 to the 1/3. Anybody coming up with a hypothesis of these fractional exponents? 2 people only? Kind of. It's math. Push the math button, it's math button. No, it just says math. Do you see it now? You just have to push the math button. Okay, I'm not asking for you to tell me the answer yet. Just a show of hands of who is coming up with an hypothesis about what. about what this 1/3 is actually telling them to do. And it's got to work for 7 and 8 too, what you're thinking about. Okay, I don't see enough hands. Huh? Do you think you know what? Okay. All right. Let's put the answers in and we can talk about what you think. So the square root of 2, what do you get for that? 0 point, 1 point, I couldn't hear what you're saying. I should know the answer. 1.41 slash, okay. And then 2 to the half gave us what? Same thing. And then we just did this one, we got 2, and then 8 to the 1/3 gave us 2. All right, I haven't done this one yet.
2.5.
Well, is that a big decimal?
It's 2.5.
Yes, so big decimal. But you guys stopped talking after 2.52, so I wasn't sure if that was. I'm doing it. Okay, so 2.520. I was doing like 3 decimals. Well, I rounded it to the 3rd place, but that rounded up the next number because it became 10. And then what's 4 to the 2/3? So what are these fractional exponents? What are they doing? So reciprocal of the index, okay. Okay, more.
The exponent is numerator and the index is the denominator.
The exponent, you're talking about 7 or 8? Well, yeah, I guess those two, yeah. The exponent is the numerator, and the index is the denominator. What does the index mean? You guys are using the word index. What does that mean? So that is not, it's not outside the square root, that's outside the, so the number is the root. It is the root. That bottom number, the denominator, is the root. What you have here are equivalent expressions. They just look different, but they mean the exact same thing. I'm going to use number 7 and 8 to explain. These mean the exact same thing. This is in radical form, and this is in exponential form. But they have the exact same answer. And what you all were saying, really good stuff. Like 2, I'm going to call the power. And 3, I'm going to call the root, which is what I was asking you to say, root. And the root comes from what kind of root it is, what the index is. The power comes from underneath that radical, whatever's on that number. Now here's the thing. How can we remember that the root is the bottom number? Because roots grow in the ground. So that funny person that said that earlier, you were totally giving away what I was going to say anyway. Oh, okay. So root, grow in the ground, so that's how I can remember that I do power over root. There is another way of remembering the power is up top, but I don't know that it's as relevant today as it was 20 years ago. What? Well, I was waiting to hear what you guys told me. Well, power lines, for the most part, used to be, you know, like big telephone poles with the lines. Mostly like 20 years ago, or whenever they were doing it, they were all up there, so we would always say the power lines are up there and the roots are on the bottom. But now a lot of power lines are buried. Say that anymore? So if you know what power lines are, then You don't know there? So power up there, root down below. All right, example 1. Find indicated real nth roots of A. So they're telling you the n, the index, telling you the index, and then they're telling you A, that's going to go underneath the radical. So here they're telling us find the third root of negative 216. So basically you're asking yourself, what to the third gives me negative 216? 6 times 6 times 6? No. Negative 6 to the third. So my answer would be negative 6. So B says the nth is 4, so that's my fourth root. And 81 is A, so you say what to the fourth equals 81? 3. Now, as we're learning this new stuff, I could, if I want, write it a different way. I could, if I want, write this instead of, it did not tell me how to write it. I could have just written 81 to the 1/4. Could have written it that way, too. But I would probably write it in radical unless they say otherwise. So anyway, so there's some rules about these nth roots, and this is probably going to be the most difficult thing that we do today. This is the part where we really need to focus for a moment. Not in a second. How about we get through this? How about we get through these? And we'll do it. It's right here. Okay, so here, this is telling us different ways that we could rewrite it. I've kind of already gone over this a little bit. And this is saying, I'm just rewriting what they have, but talking through it. A to the m over n. That's saying that we could rewrite this as A to the 1n. And then that to the m power. And this is using our rules before that says if you do power to power, you'd multiply them. So I just unmultiplied, I just factored them apart. So this is one way you could rewrite it. Another way you could rewrite it would be to take that root and put it out front, and you could have the power on the A. Another way you could rewrite it is you take the root out front, and then to that answer, you put the m around that full answer. There's like all these different ways that you could rewrite it. One way may be easier than the other. We're going to do with actual numbers so you can see it. But this is probably the hardest part that people find. And then one more thing, remember if we have a negative exponent that reciprocates it. So you don't reciprocate the exponent, you reciprocate the entire power. The exponent still stays m over n on the bottom. Some people like to reciprocate the exponent. That's not what you reciprocate. It's the whole power goes down. Okay, so evaluate each expression. I'm going to do this the way that I think is the easiest. The very first thing that I would suggest you do is factor the base. The base is the big number. So what's my big number? 16. So I'm going to factor 16. How do I get 16? 4 times 4. Factor further. 2 times 2 times 2 times 2. So 16 is 2 to the And then that 16, which is 2 to the 4th, has a 3/2 power outside of it. So what I did first was just take 16 and factor that number down. And then I still put that power outside. Then what I'm going to do is I'm going to take 2 and I'm going to multiply my powers because I have power to a power, and that means multiply the exponents. So how can I multiply 4 by 3/2? Good. 4 over 1. And then multiply straight across. So we're going to have 2 to the 12 over 2. And then 2 to the 12 over 2. 12 over 2 reduces. 2 to the 6. And then I can multiply that out. 2 times 2 times 2 times 2 times 2 times 2. 8 times 8. 2 times 2 times 2. 8. 2 times 2 times 2. What's the answer? 34. Oh, yeah. So we will be simplifying these without a calculator. B. 32 to the negative 3/5. What's the negative tell me to do?
Reciprocal.
So I'm going to do 1 over what? 32 to the 3/5. So that's still the exponent, just goes to the bottom. And then I'm going to factor 32 all the way down to prime numbers to an exponent. I'm going to factor 32. How do I get 32? 2 to the 5th. So I have 2 to the 5th, and then that's to the 3/5. Now I'm going to multiply my exponents. I'm going to multiply 5 over 1 times 3 over 5. What do we get? 1 over 2 to the 15 over 5. That reduces. 1 over 2 to the 3rd. The 2 to the 3rd is the number I can find. 1/8. Are we ready to try some? Now we're going to try 4 of them first. I said after we do these. Maybe you couldn't see what I was saying. So this is all one section. So after we do this section, we can do the break. So I've got 4 of them for you to try. I'm going to come around and look at your papers. So I'll pause the video. So type in C, the 4th root of 7, and then the whole thing cubed. I'm going to do parentheses. And then I go to math. Now here's the thing. Some of you are going to, you'll see, some of you are going to have to type in 4 and then go to math. Some of you can go to math and then choose the 5th one and then put a 4 in there. But some of you won't be able to. You'll have to try it on your calculator to know how to do it on your calculator. So don't just watch me do it. And then after that, we're going to have to do the cube root. So this is what mine's going to look like. The older calculators don't have that little spot in the corner. So try it on your calculator right now. And you should get 4.3035. Make sure it worked on your calculator. Did you use a little stop thing, or did you have to do something else? Did you have to do something extra? Yeah, I don't know about that one. Oh, that's what I had in my freshman year in high school.
That's what my
In
stepdad.
1991.
That's what my stepdad. let him use it.
Oh, you did?
Tricep, that's what you call it, yeah.
And how was it?
Great.
It's like late 40s. 30s. This is 38.
So you hear anything? So that's kind of what I had freshman year of high school. 1991.
Yes.
Okay. I just haven't seen one. I got all excited about it. I haven't seen one in so long.
You have one? We'll see. You're talking about the bracelet? You still have it?
I'm definitely talking about the calculator that Dave's carving right now. I talk about calculators. That's my thing. Just kidding. All right. The next section still that's like student practice. Try to type it in your calculator. I'm going to skip that because that's just typing in your calculator. It's not the most important thing. Next is find the real solutions. Find the real solutions. So for question A, we have to solve for x. What's the furthest thing out to get rid of, to isolate x? So we're going to divide both sides by 4. So you get x to the 5th equals 128 divided by 4, that's going to be 32. Okay. Then what cancels out if it's power? Fifth root. So to both sides, instead of doing like a square root to both sides, we would do a 5th root to both sides. Remember when we did the square root? You always had to have something else.
That's been on the board for how long?
If you do the square root, you have to have plus minus. If you do an even root, you need plus minus. If you do an odd root, it's just whatever it is. So for the odd root, when you use the 5th root, it's just the positive answer or the negative answer, whatever it is, like to begin with. This is going to be x equals what? 2. Because you can have negatives for x and you can have positives for x, but where if we do an even root, it can only be like positives underneath. It has to be that rule. Okay, so for question B, we do the outermost thing. What's the outermost thing that I need to get rid of first? The exponent. So we're going to have the 4th. So I have to do the 4th root to cancel out the 4th power. But if I put in the 4th root and that's even, plus minus goes with it. So my next step will be x minus 3 equals plus minus 4th root 21. Now how do I get x by itself? Add 3. And I'm going to put it in front of that plus minus. And I would have 2 answers. I would have 3 plus or minus 4th root 21, which the 4th root of 21 isn't something I could find. Go ahead. So let's do just a couple of these student practices. How about 13? What would we do first to both sides? Divide by 8. And I get x to the 3rd equals 8. What do I do? Cube root. And do we know the cube root of 8? Perfect. Do I need plus minus?
No.
Perfect. Let's do 15. Just right underneath it. What am I going to do first? 4th root plus minus, thank you. Do I know the 4th root of 16? If you're not sure, you could factor 16. If you're not sure, some of you know it. If you're not sure, you could factor 16 and say 16 is 2 to the 4th. You could rewrite this as a fractional exponent if you'd like. 2 to the power over root, and 4/4 is 1. Down to 1. Okay, and we still have x plus 5. So what do we do now? Subtract. So I'm going to have x equals -5 plus or minus 2. That's two answers that I can actually find. I'm getting -5 minus 2 and -5 plus 2. Numerical order, which I just messed up. I was saying it, but not doing it. Numerical order is going to be -7, comma, -3. Fancy brackets, how long has this been up? Months. No, it hasn't. The boards get clean over the summer. Oh, got it. I get it. Sure. The assignment? Where? It will be on Canvas. You can make sure. Oh, you don't want to. Just go write it down. And the book page I copied was actually it's all on the packet. So just write down the numbers you need to do. Okay, let's do 16. What do we do first? Cube root. Both sides, cube root. So on this side I get x minus 2, but what happens on the other side? Can we take the cube root of a negative number?
No.
Yes, you can.
So it's cube root. Since it's cube root.
So I can separate this to be the cube root of -1 and the cube root of 14. And then what to the third power is -1? -1 times -1 times -1 equals -1. There's a lot of negative ones, I'm saying. So the cube root of -1 is -1. Yeah. I mean, that's good stuff. So now I have x minus 2 equals, I have negative cube root 14. I did not need plus minus because it was an odd root. But I do have that negative sign because it was a negative to begin with. And then from there, I'm just going to add the 2 to both sides, and I'll get x equals 2 minus cube root 14, which I don't know the answer unless I type it in my calculator and tell you around it, but I'm not going to take time to do that right now. I don't know what you mean by just move a negative. Well, yes, but mathematically why? So the mathematically why is because we're doing -1 times 14, and the cube root of -1 is -1. That's mathematically why it's pink.
Is there like one answer?
This is, yeah, it's one answer. But I can type that on my calculator to find one decimal. No. I just do it, thank you, Frosty, but I just do it out of habit. You don't need the brackets for that. This one is just a formula where we're plugging some stuff in. We got time. Hospital purchased an ultrasound machine for $50,000. That is its original purchase price. And the hospital expects this to be useful for 10 years, at which time its value would have depreciated to $8,000. This is a formula. Down here, N is the useful life. So up here, N is 10. S is the salvage value, so salvage would be what they're selling it for. S would be 8,000. C is the original cost. It originally cost 50,000. And then we have to solve for the annual depreciation rate. So we're solving for R. Just plugging stuff in. Am I still on the screen? Better. Do you think this would be a by hand or by calculator question? Yeah, this would be a calculator question. Type it in, see if you can get the correct answer. See if you can figure out how to type it into your calculator correctly. Plus, we have different calculators, so in the room. I can try to type it in if I had the old calculator that way. So you can see if you have the older calculators, you can see how you plug in. There. So if you have the older ones that don't do the fractions, you can still get it. You just have to use division for fractions and different parentheses. All right, the last two. So let's find the radius of the figure with a given volume. So here we have the volume for the cylinder. Here's geometry. Volume of the cylinder is 1,726 inches cubed. They've given us that height is 15. We have to find the radius. They've also, oh, so nice, given us the formula for the volume of the cylinder. What if they didn't give you a formula? Look it up on the internet, right? Okay. 1726 equals pi times radius squared times 15. So we have to get radius squared by itself first. What am I doing both sides? Divide by 15 and divide by pi. Notice I did not take my calculator out yet. I will though. Then look what I have to do from there. I'm going to square root to cancel out the squared, and what do I do by square root? Okay, but does it even make sense to have a minus for a radius? Okay, so we're also going to think about it. I'm not going to just automatically put a plus minus because that's what you do. I can, but that's not going to answer my radius. So really it's only going to be the positive version of whatever that is. And I'm going to say, I'm not going to type in the calculator. You guys can type that in the calculator later. All right, 734 is the cube, the volume, and then that equals 4/3 pi r cubed. So how do we solve that one? Yeah, we're going to have to get rid of 4/3, and we can't divide by fractions. So instead of dividing by fraction, we multiply by its reciprocal. Yeah, and you could use your calculator. Okay, so I got that. How do I get r by itself? You have to divide out the pi first. Divide both sides by pi. So I have r cubed equals 1101 over 2 pi. And then finally we will cube root. If we're doing the cube root, do I need plus minus? So just on your calculator, you would type in the cube root, 1101 over 2 pi. I can type that in. Oh, where's the pi button? It's second and then the caret. Good question. I got, what did I get? I'm excited. Approximately 5.596 and meters. On the back, I copied the book page for you, so you don't have to like take pictures of it. I just copied it. I had an extra sheet, so why not? On the back. And then I'll put the numbers up there, kind of hard to see.
So you do evens or all of them?
It
Numbers?
specifies.
What?
It specifies which ones you do on those side that I'm putting out for you. There. We just stopped the video and then you guys can come back.